In this video, we're gonna show how we wired up the 240 plug for the kiln. It's just about ready to go. We haven't fired it up yet, but that's coming next. We've got this video which shows the 240 plug wiring and wiring it to the box through this conduit. And then we'll have another video that talks about our EnviroLink and EnviroVent system for venting the kiln. And then when that's done, we'll have videos about firing it up. This is a quick run through of sizing the wire and the conduit that we used for the kiln circuit. Just a quick note and disclaimer, I am not an electrician and this is what I did. It's not necessarily what should be done. That being said, I did my best to check the code and do some research, and so if you see something that doesn't look right, feel free to add that in the comments below and then we can all get smarter. So the specs for the kiln are 240 volts, single phase at 26.7 amps. Looking at the kiln website, you can see for our model of kiln, there's the model number, there's the 240 volts, 26.7 amps, and they recommend a minimum of 8 gauge wire and a NEMA 650 plug. But we wanted to kind of build for the future and potentially maybe a 50 amp welder or car charger. And so we're going to do the whole thing in THHN and trying to figure out exactly what gauge wire we should use. So the first thing I did was kind of take a look at the ampacity. Used this neat ampacity calculator from Wire. So you put in your conductor type, your wire type, conductor size. In this case, I'm trying out 6 gauge, and then your operating temperature, which around our area, that's 105 to 113 degrees Fahrenheit, 1 to 3 conductors. Then if you click the calculate button, here it shows that you can get 55 amps at the applicable operating temperatures. So I think that shows that that works. We're okay for a 50 amp circuit in the future if that's what we want to do. The next thing I wanted to check is that we didn't have too much voltage drop over the distance that we needed to go in the conduit, and so we used this app from Wire that you can download. So you can select AC, single phase, copper wire, and conduit, putting in here our length of 55 feet, a voltage of 240 volts, allowable 3% voltage drop, which is kind of the default, and then what current we want to be pulling at the end of the line. And then this thing calculates that we've got a 1% drop using 6 gauge wire, so we were good to go there. You can see in this last sheet on my notes here that I kind of ran it with a 70-foot length and we get about a 1.3% drop, so I wasn't exactly sure how I was going to run the conduit yet, but that confirmed that we could get the 50 amps we were looking for. Then the last thing I wanted to check was just the size of conduit that we needed. In the long run, I kind of wish we'd gone with something bigger, but it works and meets code. So in this is another app from Wire. You can go in and put in that you are using PVC Schedule 40 pipe. Put in the size that you're looking at, in this case 3/4 inch. Then you select the type of wire, copper THHN for us, and the size of wire, 6 gauge stranded. And finally you put in the number of wires, in this case 4, 2 hots, a neutral, and a ground. And you can see back in my notes here, we got about a 38% fill ratio, so we're good to go pulling the wire. It certainly was difficult with all the bends that we had, but at the end of the day, we were able to do it. So at the end of the day, that's what we did. Like I said, if you see something that we did wrong or something I should have considered, feel free to let me know in the comments. I'm intending to get this permitted at some point here, so I'd love to know if something isn't right, either here or in the rest of the video before I do that. The panel pulled off here, and I saw on the underside here, I got an open punch out, a couple open punch outs for the wire. And so I very carefully cut out this hole just by using a utility knife on the paper. Kind of cut some crosses across the circle and then scored the paper, pulled the paper off, and then used my small chisel here to just kind of chisel out the drywall to get to the back paper. And then I cut through the back paper very carefully just to make sure. You can't see in there because it's dark, but I didn't know what was behind there, so I just wanted to make sure it fit. So I had used this J box here to mark the hole, and now that will be able to just kind of fit snugly in there. And a good fit. I had to kind of clean off the edges to get that tight fit. But yeah, that'll go there. And then the conduit will run up to the ceiling. Take a 90, run across to the end there, take a 90, run across to the other side of the door, and then take a 90 down to the kiln, which you can barely see back there. Yeah, so we'll start getting the conduit put up, and then I think I'll be able to pull with 390s. It's less than 360 degrees of bend, so I think I'll be able to fish tape the whole thing out, but I guess we'll see. I'm using a laser level to get a straight line up so I'll know where to attach the conduit once it's up there. Just cut the first length for the vertical run up from the J box at the breaker box, breaker panel. I just used a hand hacksaw, cuts super easy. For putting these up, I got these little C-clamps. I got some 1/2-inch lag bolts for each, which is probably overkill, but that's what they had at the big box store. So that's what I got. And then I'm gonna put them every 32 inches. Here is the start of our conduit run. Found a handy way to hold up some conduit. Got an old window cleaner in order to bend the corner here and get across this stretch at what I'm hoping will be a right angle. I used a little laser rangefinder and magnetic bracket to stick the rangefinder up there parallel with the wall, shining a dot, and then marked the wall on that side. And now I can use the length of pipe and my angle bracket to measure that distance out correctly. Got my little made up jig here, so I can run the conduit. So now we're about to make the run down the wall to our box. And here, I'm holding up the elbow at the center line. I set up a laser level through the center of the stud. So I've got the bracket attachment centered on that. That puts me with the conduit where I need it, and so I can mark the end of that conduit and then measure from here over to where we have the end of our conduit run there. And then make sure I'm accounting for the slit between the conduits here.
You don't want to you need to take it down again.
Yeah, it's about the same because you gotta go in there and in here. So if I'm measuring the conduit with the attached bell on it, from end to end, I have to add the amount that goes into here.
Yeah.
All right, I'm gonna do that now. Conduit is done. We've got it anchored close to the box there with the first anchor. And coming up, I realized after I had set the first 2 anchors that there is a code requirement for 3/4 inch to 1 inch PVC conduit to be anchored every 36 inches. So I got kind of a goofy spacing there just to make sure I get that. Then we run all the way across, along the back wall, and then down to the junction box, which I'm actually gonna go back to the big box store and get a larger size, just because I'm running 4-wire, and I'm gonna coil the neutral up to be used later for a car charger or something like that, but I'm not using it now, so I want a little more room in the box. I've got some helpers today.
Did you mean red box store or blue box store?
Or orange or blue.
Yeah.
Probably the blue box store. And then we still got the workbench here. This has been really handy, rolling it around and using it. I still need to finish it.
You also need to lock this wheel.
Yeah.
And we've got a lot of views from it too.
Yeah, and I got lots of helpers today. Here's the end of our fish tape. It was actually pretty easy to, sorry for the wiggle, to run it through. We got the deal hanging over there. It's about 50 feet of conduit. All right, learning experience. The 4 wires together with the fish tape were too large for
Way too big to go through
the conduit. Well, not way too big, but barely.
Yeah, just the size of the fish tape too big.
So we taped the fish tape to the green wire, and then I think the red wire, and then the
Yeah, we staggered the white
blue
wires
wire-
here, and then the red
the-
wire and the black wire
yeah.
are there.
Anyway, they're staggered, so hopefully it'll pull better and it's not too much strain on that. There are our coiled lines waiting. We managed to get it pulled through to the end here, so now I need to get in and fish it into the box. All right, so we're gonna wire this 240 circuit. We've got our 4 strands of number 6 stranded wire for wires, number 6 stranded wire insulated. We are actually not going to use the neutral right now. That's for a later project, so this will just curl up in the box somewhere. But right now we're going to flip the breaker and take the panel off, and then just test the voltage to make sure that everything's off. Power is off. People should start complaining any minute now. Mine has these nice six bolts, nice even panel. This was put in 2017, so it's pretty new. All right, there's my knee under here. I've got the penetration up there, kind of pinches the panel, which is a nice little bonus. So there we go. Pull that off. Trying to figure out the best way to get these wires. Oh, turned off. Get these wires through this hole and then through the hole up in here. I would like to avoid having to cut a big hole in the top of the drywall if I can. So if I can get these, I've got extra wire, so if I damage the insulation, I can just cut it off. Get this to where I can grab it. Okay, here's the audible. So, since that 90 was just not gonna work, I went and cut a slot in the drywall and then ran the conduit directly into the box. So it is all nice and secure. I don't have to worry about sleeving the THHN before it gets into the box. And then this will just bend up like that and go straight into the conduit, the solid or the rigid conduit, and I can just run the wire down directly into the box. And then I will I think I'm gonna 3D print a little back cover for this so it can be kind of small. You could use wood or something else, but I have a 3D printer, so I think that's what I'm gonna do. There, the wire is pulled. Got the little flexi conduit on there onto the rigid, and now I just need to pull the wire the rest of the way through, and we can make the connection. All right, we got our wire running down here. I'm kind of zip tying it off to keep it in place. We got the green wire to the ground bus. I think we got the green wire to the ground bus, and we're tightening that down. And then we'll hook up the wires for the breaker. I think we're all set. Got our wire coming in from our conduit, runs down, got it kind of tucked away. I've got the neutral wound up here and capped. And that will be if we ever put in a welder or car charger, then I've got that wire ready. I've got the breaker, 30 amp breaker for the kiln set up in its new location. Wires in there. And then I've got the ground on the ground bus, which that took some doing. Got that 6-gauge wire, which is not necessary for the 30 amps, but is necessary if we go up to 60 someday. So anyway, it's future ready. So we're gonna do the knockouts on the panel and then put it back on, and everything should work. The last thing I'm gonna do is install this wet cover protector, which isn't technically needed, but I think it looks better, and then it will just generally keep hands away. Well, when we're not using the kiln, we'll keep the breaker off anyway. But, you know, with 240, doesn't hurt to be safe. And there she is, all done. We are going to go to the Clay Art Center here shortly to pick up a couple witness cones, or pick up a couple boxes of witness cones, and we'll do our first firing.